In our last class, we have discussed about subnet mask. We have discussed how to identify the network ID, host ID. This all basic things we have understood. Then we have discussed one important concept called CIDR, class interdomain routing. This is what we have discussed, and today we are going to start with subnetting. So, anyone, what is subnet mask? What is subnet mask? We have discussed this in the last class. What is subnet mask? Okay, we will just try to recall everything quickly and then we'll move ahead and start our core topic, that is subnetting. So, a subnet mask is a numerical value. Subnet mask is a numerical value that describes a computer or a device how to divide an IP address into two parts. It's a numerical value. It helps you to divide IP addresses into two parts. And what are those two parts? Network portion and host portion. Everyone remember this? This we have discussed in our last class. The subnet mask is a numerical value that describes a computer or a devices how to divide an IP address into two parts, and those two parts are network ID and host ID, or you can say the network portion and the host portion. So we have also discussed that the network part, the network portion, the network element, what it does, it identifies the network, identifies the network to which your computer belongs. And we have set up an example that it is something like a city or area name. And what is host? Host ID or a host element. It identifies unique computer on that network. It is something like your home number, villa number, flat number. Then from the beginning, we are learning that an IP address is made up of four digits separated by dots. It can be four digits, digit one separated by a dot, something like that, like this, where x is a number between 0 and 255, where x stands for number between 0 to 255. IP address is a four digit number separated by dots. Now, we this all basics we have understood. Then we have discussed something called CIDR, correct? What is the purpose of CIDR? Yes, anyone can put in the chat box. What is the purpose of CIDR? What is CIDR? This also we have done using many examples, right, in our previous class. Anyone remember CIDR? Yes, guys, be interactive. Anyone remember what is CIDR? Imran, I am not asking full form. What is CIDR? Please put in the chat box. What is CIDR? Anyway, we will discuss everything. We'll start now. So, before moving with CIDR, let me tell you that the IP addressing, which we have discussed till now, we have discussed different type of classes, then different type of IP addresses, private IP addresses, public IP addresses. So within classes, what we have discussed is something called classful addressing. So what is classful addressing and what is classless addressing? This we are going to discuss now. Classful addressing and classless addressing. So in classful addressing, we have discussed that the IPv4 addressing is divided into five classes, right? Class A, class B, class C, class D, and class E. These classes of IP addresses we have discussed, and and we have also discussed that these classes have a fixed length, right? If it is class A address, if it is class A address, then in class A address, what is the range? Yes, anyone? What is the class A address range? How many network? What is the network ID and host ID of class A? We have discussed this right in the previous class. Can anyone put it in the chat box? In class A, how many do you have the network address and host address? How many network addresses are there and host addresses are there? Yes, anyone? How many bits of network and how many bits of host? Please put in the chat box. We have discussed this, right? If it is a class A, then you have 8 bits on the network side and 24 bits on the host side, meaning that you will have a million of IP addresses available over here. Then similarly, you have in class B 16-bit network ID, 16-bit host ID. In class C 24-bit network ID, 8 bits host ID. This all thing we have discussed in our previous class. Meaning that the network bits and host bits are same over here according to the classes. In the scheme, network ID and host ID changes depending upon the class. As soon as your class changes, if it is class A, you will have 8-bit fixed network ID, 24-bit fixed host ID. If it is class B, it is fixed 16-bit network ID, 16-bit host ID. If it is class C, it is fixed 24-bit network ID, 8-bit host ID. This is fixed over here, right? On the other hand, and this is nothing but a classful addressing where the classes where your network portion and the host portion are fixed always. This is nothing but the classful addressing. On the other hand, you have something called CIDR. CIDR stands for class inter domain routing. Class interdomain routing. So this is something which was introduced in the year 1983, and it this concept CIDR, class interdomain routing, it has replaced the classful addressing. It has replaced classful addressing, meaning that it is no more a standard that if you are using class A, it will have a fixed network ID and a fixed host ID. No, it will vary. And this kind of IP addressing, that is classless IP addressing, allows the user to do something called as VLSM. Stands for variable length subnet mask. Now, let me tell you something. In class A, when I say class A, and I say that it has 8 bits network ID and 24 bits host ID. So I told you instead of writing 8 bits, so what will be the subnet mask? The network bits will be 11111111, and remaining host bits are there. So it is 0000000000000000, then 0000000. So which is nothing but the subnet mask you will write as 255.0.0.0. If you talk about class B, it is 16 bits network and 16 bits host. So you can write this something like, when you convert it into binaries, you will say 1111 8 times and 1111 8 times, and the host bit will be 0, right? And when you write it subnet mask, it will be 255.255.0.0. So I told you something like, instead of writing this complete 255.0.0.0, what you can do is, when you say 255, it will be 11111111, right? So you can say that instead of writing complete like this, /8, it is a CIDR value. Over here you will say /16, it is a CIDR value. In class 8, you will say /24. But the thing is that the classless addressing has completely replaced the concept of classful addressing, that you don't need to always remember, or you cannot say that if it is a class A address, it will be 8 bits network ID and remaining 16 bits will be the host ID, 24 bits will be the host ID. This is no more a concept. The classless addressing allows the user to do a VLSM, variable length subnet mask, meaning that if it is a class A address, this 10.0.0.1, for example, is a class A address. Usually in classful addressing, if I say that it is a class A address, you will say that the CIDR value, or the subnet mask of this will be 255.250, sorry, 255.0.0.0. And if I say that what is the CIDR, you will say /8. If I will write 172.16.0.1, you will see that 172, yeah, it's a class B addressing. So you will say that the subnet mask is 255.255.0.0, and the CIDR value will be 16. If I write something like 192.168.3.5, you will say that it's a classy addressing. The subnet mask will be 255.255.255.0, and you will say that the CIDR is /24. But this is no more applicable. This concept is no more applicable. Now, there is something called classless addressing, and the CIDR value will be changing. It allows the user to use the variable length subnet mask. So even though you are using 172.16.10.0 network, for example, and you can say that it will be /24. This is what something called as variable length subnet mask. Like, it is not a standard one, it is not standard practice what we were learning till now, that if it is a class A address, the subnet will remain 255.0.0.0. No, even though you're using a class A address, you can define the variable length subnet mask, and this is what we are going to learn in subnetting today. Till now, whatever we have discussed, whatever you can see on the board, everything is clear. If anyone has any questions, any doubt, please feel free to ask, because without getting this concept clear, you cannot learn subnetting. Anyone has any questions? Yes, anyone has any questions? Or we can move ahead. So, moving ahead with the discussion now. So, there are some rules when you are doing a CIDR, class interdomain routing, which allows you to use variable length subnet mask. There are some rules, and there is a benefit when you are using the VLSM. Whenever you are defining the variable length subnet mask, it will allow a proper allocation of the IP addresses, and it will help you. One second. VLSM, a very important concept in networking, or you can say that whenever you are learning a subnetting. So, VLSM stands for variable length subnet mask. Okay, variable length subnet mask. It helps you to efficiently use IP addresses. Now, let me give you one example. This is our network 192.168.1.0. So now, if I will ask you, what is the class of this IP address? Yes, anyone? To which class this IP address belong? 192.168.1.0. Please put in the chat box to which class this IP address belongs. 192.168.1.0. Imran says it belongs to class C. What about others? Daniel, Sohail, Ala, Muzaffar, everyone is there with me? It belongs to class C. So if it belongs to class C, please tell me what is going to be the CIDR for this, or what is going to be the subnet mask. Put the subnet mask as well as the CIDR value. Ala says 24 is the CIDR. What about others? 24. Yes, it's a class C address, so meaning that 24 network ID and 8 bits will be host. 24 bits will be network and 8 bits will be host. Now, this block will have how many IP addresses? Yes, anyone? How many hosts will be there in this? How many hosts will be there? See, you have written that slash 24, meaning that you will have 24 will be the network portion, meaning that 192.168.1 will remain same, but the changes will be happening on the host side. That is 0, that will be 1, then 2, 3, and we have IP addresses. Uh, the octet in the IP addresses can be from 0 to 255, meaning that you will have total 256 IP address. In this, you will have 256 IP address. How come you come to the conclusion it will be 254? No, it will be 256. Can anyone tell me why you told 254? Yes, Dania, Ahmed, or just everyone copied to Allah. So in this, there will be 256 IP addresses. Now, consider in your office, No, Allah, don't go behind that 2 raised to n minus 2. That will come later, and that is something totally different. My question was, how many IP addresses will be there in this block of 192.168.1.0/24? So the IP addresses will be 256. I didn't ask whether it is usable or it is not usable. I simply asked how many IP addresses. It will be 256 IP addresses. Just forget it. Usable, not usable. Now, consider, consider you are in your office and you only need 8 IPs for your network. So, don't you think that utilizing this complete block is a waste of IP addresses? Yes or no? Don't you think that using this 256 complete block is a waste of IP addresses? Yes, it is a waste, right? Now, you are at home. We have learned that private IP addresses are free of cost. Since it is free of cost, you can waste it, no problem. But just consider you are working on the service provider network, you are working on in ISP. Over there, you are having a public IP address pool. These public IP addresses are the paid IP addresses. You don't get it free of cost. You are taking the lease line, internet lease line for your company. You have to pay for the IP address as a lease. You have to pay the amount for these IP addresses also. So now, being working on a service provider network, let's say that you have this pool with you 133.123.113.0/24. This is one of the pool with you, and you are working for the service provider, and customer comes to you and asks that, sir, I need the internet lease line from you, and at the same time, I need the IP addresses for my internal requirement or for my company requirement. This is my requirement that I need total 12 IP addresses. Now, the customer is asking you, he or she needs 12 IP addresses. You have this complete pool. So, will you give him the complete pool? If you give him the complete pool, your boss will say you are a fool, just get lost from here. So, because it's the paid service, he is asking 12 IP addresses. He is going to pay for the 12 IP addresses. And if you give him the complete 256 IP addresses, it is totally a nonsense idea, useless idea. So, for this, what you are going to do is nothing but subnetting. What you are going to do? Subnetting. And this is what we are going to learn today, how to do subnetting. So, everyone is ready to learn subnetting? Yes, guys, please be interactive. Huh? Everyone is ready to learn subnetting. That's good. Before that, I need something from you. I'm putting one example over here. What you all have to do is you have to calculate the CIDR notation for me. This is the IP address 192.168.1.0. Okay, and the subnet mask of this is 255.255.255.0. Please put in the chat box what will be the CIDR notation for this. Imran says it is slash 24. Is it right? It is not 20, slash 24. Please put in the chat box what it will be. Yes, guys, be quick. What will be the CIDR notation for this IP address with the subnet mask 255.255.255.0? That's right. Slash 24 is right. But the problem with you guys is confidence. Imran has given the right answer. I told that he is wrong, and everyone started to think what is the right answer. You have to be confident that if it is slash 24 means it is slash 24. And so he is asking me, is slash 24 right? Why you are asking me? You should be confident that yes, it is right. Now, subnetting is a process of dividing a large network into smaller networks, and this is called as subnet. So subnet is like a smaller group within a large network. Now, how to do subnetting? We are going to learn. Now, consider you are working with the ISP internet service provider, and you have this network available with you 192.168.1.0 slash 24, and a customer comes to you and says that, sir, I need six IP addresses. I need six IP addresses for my company requirement. So we will learn now how to do the subnetting, how you will allocate in the six IP addresses. So if everyone remember, I told you that in every subnet, if it is 192.168.1.0, if it is 192.168.1.0 slash 24, the first IP will be, what will be the first IP? Yes, anyone? Allah is asking, but we have private IP. Where is the wasted IP which we are not using subnetting? Okay, Allah, I will give you an example. Consider now you are using the IP scheme, let's say 172.16.1.0. Okay, by default it is a class B addressing, and your question is why there is a no waste. Yes, there is no waste. If you want to use the complete block even for the two or three IP addresses, you can use, but you should know the subnetting. Why? Because even on your WAN side you have to do the subnetting, right? So the subnetting concept is very important. There is no waste, but why you are using unnecessary a big block? The reason why you should not use a big block, that also we will discuss when we will be doing the configuration of the switches. Just hold on one second. Okay, so Allah question was there that we have private IP addresses, then where is the waste? So Allah, it is not only about the wasting of IP addresses, but it is also about some memory utilization and all. That are multiple things apart from that we are going to learn at the right time when we will doing a switching. At that time we will understand how much it is painful and how much the resource utilization you can save when you are doing a proper subnetting. That we are going to learn, but for now just understand that you can just save the IP addresses from a wastage as a basic understanding, but in the coming time we'll understand that also. Your question will be addressed, don't worry. Now, we all know that we have learned that the first IP will be, what will be the first IP in a complete network pool? What will be the first IP? The first IP will be network address, right? What will be the first IP address of each in each subnet? Network address. The first IP will be network address. It will be providing the network address details, and the last IP will be the broadcast. In every network, in every subnet, the first IP will be the network address, and the last IP will be the broadcast address in every subnet. Huh? And what is subnet? Dividing the larger network into the smaller portion is one subnet. So every time, remember that the first IP in every subnet will be the network address, and the last IP will be the broadcast address. And for your information, these two IP addresses, these two IP addresses are not usable. Are not usable. Meaning, you cannot configure these IP addresses on your host. If you want to configure the IP address on your computer, so you cannot configure 192.168.1.0. Okay, nor you can configure 192.168.1.255. So the usable IP addresses will be, for this network, usable IP addresses will be from 192.168.1.1 to 192.168.1.254. This will be a usable IP address. So in every subnet, the first IP and the last IP are not usable, meaning two IP addresses in every subnet will be not in use. So whenever you are doing a subnetting, meaning whenever you are breaking the larger network into a smaller portion, you have to remember that you must be adding these two IP addresses which are not usable. So now the customer comes to you and says that, boss, I need the six IP addresses for my company requirement. And what network you have? 192.168.1.0/24. Correct? So how you will be doing the subnetting? We all know that the two IP addresses will not be in use, right? And there, whenever you are doing a subnetting, you have to remember that concept of power of two, which we have discussed in our first lecture. So as soon as the customer comes to you that I need a six IP addresses. So what you will do is, very first you will be adding plus two. Why? Because in every subnet the first and the last IP are not usable. So the six IP plus two will become eight IP, right? Now what you will do? The second thing, what you are going to do is, you will be calculating the power of 2 up till the time this you reach the 8 IP addresses. This one, so 2 is to 1 is 2, then 2 is to 2 is 4, and 2 is to 3 comes to be 8, right? 2 ratio 3 will be 8. Just hold on, I'm getting one call. Okay, so we have discussed that the customer needs 6 IP addresses, and we know that in every subnet, two IP addresses will be of no use. The first one is network ID, and the last will be the broadcast ID. So always you will be adding plus two to the requirement. Now total comes as a 8 IP addresses. Okay, so the 8 IP addresses you are going to give to the customer. So the 8 IP addresses will be 192.168.1.0 192.168.1.1, 192.168.1.2, 192.168.1.3, 192.168.1.4, 192.168.1.5, 192.168.1.6, 7. These are the 8 IP addresses which customer will be using from your block. But now the question comes how you will give it to customer and how you will be defining the subnet mask. That is what we have to learn in subnetting. How you will define the subnet for this 8 IPs block. So everyone knows that IP addresses is a 32-bit IP address, 32-bit address, right? IP address is a 32-bit number, right? It is a 32-bit number. So when you say that you need to give the 8 IP addresses, you have taken the power of 2, which is 2 raised to 3. So what you will do, what you will be doing, and we also know that how the subnet mask is written. If it is a 32-bit number, the subnet will be 255.255.255.255. Now you will say 192.168.1.0, the first IP, and to define the CIDR over here, what you will do, IP address is a 32-bit number, and the 8 IP addresses you have to give, which is the power of 3, right? Power of 3. So what you will do, you will be subtracting this 32 minus 3. How much it will be? 29. And over here, you will be giving the CIDR value as 29. Now, if you want to write the subnet mask, so you will say that it's 29, right? This is going to be 11111111, then 11111111. 24 bits are there, and then 3 bits more you need, right? You need 3 more bits. Or else the simpler way, instead of going with this, go with the simpler way. 29 is there, right? 255, 255, 255. This is 24 bits. And what you do, the last octet, again you have 256 IP addresses, right? So simply from 256 subtract 8 IP addresses. Subtract 8 IP addresses, which will be 248. And you will write the subnet mask as 248. Now you have allocated these IP addresses to the customer. Again some customer comes to you and request for that I need 14 IP addresses. 14 IP addresses are required. You have already allocated first 8 IP addresses. So now 14 IP addresses are required. So what you are going to do is you will add plus 2. It will be 16, and 2 raised to 4 is 16, right? So the first available IP is 192.168.1.8, and you have to write the CIDR. So 32 minus, what is the power? 4. Now 32 minus 4 is 28. Now if you have to write the subnet mask, so it will be like 192.168.1.8, and the subnet mask will be 255, 255, 255, and 16 IP addresses. 256 minus 16 is 240. 216 hosts are available. So the pooled The customer will be using 192.168.1.8, which is going to be the network ID. Then the next IP will be 192.168.1.9, 1.10, up to what will the last IP? Anyone? 192.168, 1 dot. What will the last IP of this pool? 16 IPs will be there, right? Yes, anyone? It will be 192.168.1.23, the last usable, the broadcast IP. The last usable IP will be, so you can say that this is network IP, host IP, host IP, last host IP, and this you can say broadcast IP. Yes, sir. Is it clear? How to do the subnetting, how to calculate the CIDR, how to calculate the subnet mask? Is everything clear? Yes, guys, please confirm in the chat box. Or if anyone has any doubt, please tell me so that I can explain again. And remember, this is a powerful concept which you will be using continuously wherever you're doing. You're doing the routing lab, you're doing the switching lab. Now, now I have this network available with me 192.168.3.0/24. My requirement is for the first customer. With the first customer, I need to allocate 8 IP. Okay, so let's say Daniel, you will do the subnetting for this. You have to allocate 8 IPs. Second customer comes and he needs 16 IPs. And this subnetting, Imran, you will do. Third customer comes. Hold on. Third customer comes and he needs 13 IP. And this subnetting, Sohail, you will do. For fourth customer, again 13 IP are required. So hold on. Think. Okay, let me write down again. I have this network block available with me. 192.168.2.0, and the first customer I need to give 8 IP. So this subnetting Daniel will, and remember that it should be the, like if I'm saying 8 IPs will be done by Daniel, so you have to calculate that if Daniel is doing a subnetting for this 8 IPs, what the next IP the subnetting will start, and accordingly you have to proceed. Huh? So just refer to this whiteboard over here and do it accordingly. 8 IPs subnetting will be done by Daniel, then 16 IP requirement is there, and this will be done by Imran, and then again I have 16 IP requirement. This need to be done by Sohail. 13 IP requirement is there. This need to be done by Ala. Then again I have 10 IP requirement from here. So Danish will be doing this subnetting. Then I have 24 IP requirement. Muzaffar will be doing this. And I have 32 IP addresses requirement. Ahmed will be doing this. So just start doing the subnetting part. Okay, just do this, and then we'll proceed further. Do the subnetting for this block. Write down the subnet mask. What will the subnet mask? What will be the IP address range, and what will be the CIDR value? What I need from you is, for each subnet, each and everyone will be writing the IP address range, subnet mask, and CIDR value. Okay, you have 10 minutes. Till that time, complete it. Be quick. Now, moving ahead with the discussion. Oh, just see on the board over here. This is my requirement. This is my requirement that I have a block of 192.168.3.0/24. Okay, I need to give 4 IPs to customer 1, 2 IP to customer 2. I need to give 8 IP to one customer. I need to give 120 IPs to another customer, and Daniel will be doing the subnetting. I have another customer 192.168.4.0/24, and I need to give 3 IP to one customer, 6 IP to another customer, 128 IP to one customer. 128, 125 IP to one customer. And this is something Danish will be doing. I have one more network 192.168.5.0/24, and my requirement is I need to give 8 IP, 24 IP, and 32 IP. Okay, and this subnetting Muzaffar will be doing. I have one subnet 192.168.6.0/24, and over here I again need to give 10 IP to one customer, 16 IP to another customer, 32, 64 IP to another customer, and this will be done by Ahmed. I have one requirement 162, 160. So 7.0/24, and my requirement is one customer I need to give 12 IP, 16 IP, and I have to give 123 IP. This will be done by Imran. Okay, and 8.0/24, 16 IP, 20 IP, and 100 IP. This will be done by Sohail. So your time starts now. You will have 15 minutes to complete this task. What I need from you is IP address range for each subnet, subnet mask, and CIDR. Is it clear? So everyone has to do their own task. 15 minutes from now, complete it and put it in the chat box. Your time starts now. So guys, you can do one thing. I have received the response from many of them. For few of them, it is remaining. You can do it as a homework, and when we connect in the next week in the morning, I want the reply. Just note down this requirement what I have given, and in the next lecture when we will be starting at that time, from all of you I'm expecting the reply. So I believe that everyone has taken, and who has given the reply, again they can post it in the next week, so that I will have a correction on it if any mistake is there. And once I am confident that you people have learned how to do the subnetting, how to create a subnets, then we will be moving ahead with the advanced topic. And from the coming week, we will be having more over practicals and less theory. There is something, a small topic, CCNA topic, virtualization and cloud computing, which is remaining. So we will complete that, and then we will move ahead with the advanced topic, which are the switching parts, routing concepts are there. These all things from the basic will start, and we will go to the advanced level. Everything will be covered. Don't worry. Okay. Thank you. Bye bye.